TTL Computer II. Today we're going to be taking a look at testing our memory address register card. And as you can see, we already have this powered up and the card is plugged into our testing jig. And we have our testing jig wired up substantially similar to the same patch pattern that we used for the program counter. Again, I will post the patch cable pattern and the test plan. I'll post those both to the community pages. But we have our low order memory address register coming to, low order byte coming to our 8-bit display. We have our data bus, again, patched into our switch number 1. We have switch number 2 patched into our control signals. And we have memory in high, memory in low. We have counter enable, and then counter out signal is our last signal on the switch number 2. And then we have button number 1 is again wired as our T clock signal, and button number 2 is our clear signal. And those are both, patched in through the switches header. Okay, again, the main difference between the program counter and the memory address register is that the program counter is a 8-bit output. So they're both 16-bit registers, but the program counter only does either the high byte, outputs either the high byte or the low byte. The memory address register outputs the full 16-bit address on the card edge. So how are we going to handle that? Because we only have an 8-bit display. So what we're going to do is, so I have my test plan again here, and again, I'll post that to community pages, but we're going to run through this. And spoiler alert, like last time, I already ran through our test plan, and the card actually passes our tests. So a bit of a spoiler there. But now, since we only have the 8 bits, so what we're going to do is we have to run through our test plan twice, right? We run through the plan one time. Our first time, we'll just be looking at the low order byte, and then we will have to repatch the output into the high order byte, and then we'll run through the test plan, the same plan again, and we'll just be looking at the results on the high byte of the address register. So, but we're just going to run through the test plan, looking at the first 8 bits of the address. There's not too much to see when we do the test the high order bits, so I'll spare you going through that. We'll just go through looking at the low order bits, half of the test plan. Okay, so let me get going with this. Our data is low. We have our signals, control signals are all high, and our outputs are 0. All right, I'm going to do a clock press. Good, and we see nothing here because the output display is still suppressed. So that's a pass. Now we're going to bring the output low, and there we go. So we see I did the clock press before, and the display was disabled. I enabled the output, and we see the result. So that is a good test. Okay, now we're going to just do a clear test, and that's good. All right, now we're going to do, so we're clear and we're reset, so now we're going to do a simple, just a simple counting test. 1 and 2, and that passes. Okay, and we should be looking at, the high order address to validate that 0, but we're not doing it now. We would do that in the second pass through the test plan. Okay, so we just did our counting test, so now we're going to disable counter enable. We're going to bring low, and that's done. So now we'll just clock press and no counting, as it shouldn't when the counter is disabled. So that's a pass. Okay, and again, we're just going to do memory enable back high, and here we just have a clear test again, and we do. All right, so that's passed. All right, so now we're going to do our first ripple carry test again. And we're going to start doing that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. And here's our ripple carry out. And that's a pass. Okay, so we're good on that. Now we want to bring counter enable low. Okay, we want to have FF on our data bus. And we do. And we want to do memory in low. We want to enable that, bring that low to enable that. And we are going to clock that in, and that's a good test. So we had FF, and we clock that in. And that's a good load test. Bring that back high. And now we want to bring memory enable, counting rather. That's high to count. That's high. All right, and this is our ripple carry out too. So we're at FF. We want to do 1 clock. That overflows to 0. Now we want to see in counter out high, we want to see a 1, but we can't look at that now. We would look at that in the second pass. But the overflow is correct here on the low order byte. All right, we want to bring memory enable low. And dbus is FF. Memory in low, we want to bring that low. Okay. And clock. All right, so we loaded that in with FF. Memory in low back high. Now we want to bring memory high, memory in high, low to enable that, and we did. Now we want to clock that in, but we're looking at the low byte, not the high byte. So we did that. Bring this back high. Where are we now? Okay, I need to switch pages. Okay, here we are. We want to enable the counter, and we have. And now we want to do a clock press. Okay, that was our ripple carry 3 test. Again, so that cycled through. We want to see hex 10 in the high order address byte, but we're not looking at that now. We will look at that in the second phase of the test. All right, so now we want to bring memory counter enable low, and it is. FF on our data bus, memory in high and memory in low. We want to bring these down low. We can load those both at the same time. We did. Okay, that's FF loaded in, and that was loaded in on both the high byte and the low byte. Okay, bring these back high. And we want to have counter enable high. Okay, and this is our rollover test because we have FF in both the high byte and the low byte of the address register, and we want to do a single clock, and that rolls over. Okay, and again, this is just the low order byte. We want to, in the second pass, we would look at the high order byte, and that's good. All right, so those are all our primary tests passed on the first pass through. So the low order byte behaved as it should for our test plan. And then we're going to just do a final clear test. One more clear test. Counter low. We have FF on our data bus. memory in high and memory in low. We bring them low to enable those both. We have that. We can clock, so we clocked in FF to both the high and the low. And we're going to disable the load, re-enable the counter. And this is our final clear test. And that cleared. And again, we're just looking at the low order byte of the address. On our second go through, we would look at the high order byte. But that's all good. All right, and I said I'm not gonna run through the second pass because there's just really not too much to see. So that is a successful test of our memory address register card. Okay, so we are doing pretty well now. We have 3 cards completed. We have our clock card completed, our program counter card completed, and our memory address register card completed. So we're proceeding along pretty good. What we're going to do in our next video is I think I'm going to pause from our PC board construction, and we're going to consider the control circuit issue that I became aware of. And we'll talk about that and look at the solution in our next video. So that's it for today. Thanks for watching.